So, hello, I'm a designer.
I'm a developer.
Right. So my name is Andres. I am from Argentina, and I'm showing here my Canadian friend and colleague, Brian. We both work at Red Hat, and during the next 50 minutes, we are going to show you how developers and designers can build bridges to generate outstanding results. So by show of hands, how many of you consider yourself developers? Right, and that fire is the best transition you can have on Keynote. And how many of you consider yourself designers? Yay, go designers. So we're going to talk about the different scenarios and discover where the middle ground is based on our experience working together. And then we're going to give you a sneak peek of the Keynote Demo that is going to happen on Wednesday to showcase some very cool CSS and JavaScript techniques we use to build it. At the end, we're going to have a few minutes for questions and answers.
First, a word of warning. On Wednesday is the mobile birds of a feather session, which ends up being a bit of a Nerf gun battle. But since we're both 10-year-old kids trapped inside an adult's body, we couldn't help ourselves, and we brought our guns along, and we're not afraid to use them.
No.
So be sure to attend the BOF on Wednesday and to see Jay Balunas when he brings out the big guns.
And that's going to be super fun. So let's get started today. So this is Santiago Calatrava, and he's one of the best architects alive. He builds bridges. And design creates structures that are not only functional but also beautiful and robust. So Calatrava is a unicorn. He's a designer and a developer. He has a degree in architecture and a second degree in civil engineering. We, on the other hand, are by no means unicorns. We are at best horses wearing a party hat. But his attention to detail and his user-centric approach is something he shares with other great architects, like Frank Gehry, Frank Lloyd Wright, Le Corbusier, Mies van der Rohe, or Antonio Gaudí. They all innovate by finding the balance between the developers, the design, and development. But by leveraging that balance, they use light, materials, and different spaces to immerse people in experiences that goes beyond a simple structure. And one of the best examples of this is here in San Francisco. Not far from here, in the Golden Gate Park, you will find the California Academy of Science, one of Renzo Spiano's best design. And if you haven't been there yet, go. Forest. The web has also learned that outstanding results are achieved when you put the user in the center and you bridge the gap between the functional and the delightful. So products like Mint, Square, and Simple, they've all done a fantastic job by getting the design details right and bridging the gap between the design and the development. They all started by unproven products, but customers trust them to store financial details, safeguard their accounts, and process payments. But UX changes and improvements go beyond the UI and the visuals. The Argentinian branch of the ICBC Bank has put together their UX team to work with the engineering team in charge of the customer support phone system. So I don't know if any one of you called customer support. It's usually one of the worst experiences you will ever find. And actually, I did a Google search about what are the worst experiences any human being can have, and number 5 is listening to Justin Bieber. And they could predict what a user was looking for with 83% of accuracy. That means that when you call ICBC Bank, chances are that they will offer you what you're looking for in the first option they offer.
Andros, those results are fantastic. But of course, they're not easy to achieve. Designers and developers think differently. We come at problems from different angles and try and achieve solutions differently. So let's first start by defining what we both think a developer and a designer means to us.
Right. So when I think of a developer, I think that you guys just make And you're actually not alone. A colleague of mine sent me these lines a few weeks ago. But designers do much more than making things look nice. We care about typography to the point that we get annoyed if the elevator number has the incorrect kerning. And we generate endorphins when we see good alignment. That's why this poster is not even funny. UX designers help, or actually build solutions to help users achieve their goals. We are lawyers defending the user. And my job is to make sure that everybody that works with me understand our users and keep them front of mind as we do all our design solutions, product decisions, productization decisions, all the way through the process. So design is not just how it looks and feels, it's also how it works.
On the other hand, developers think logically. We break problems down into solvable pieces. We just make things work. A developer will devote himself to crafting an API or data structure that optimally solves a problem. We'll implement that solution and optimize it for performance, reusability, scalability, and will provide robust implementations that meet our coding standards. Unfortunately, more often than not, developers don't know how to apply that same level of diligence when building out the UIs to their applications. We end up with a Swiss Army knife that more often is dictated by the APIs available and visually represents the underlying data structures. But I do agree that we have one final goal. We want to help the user achieve their goals. So even though our skills are very different, we can come together with the one goal in mind of improving UX, user experience.
Right. And there are 3 key actions we can take to get good user experience and bring designers and developers together. The first one is to trust, respect, and communicate. I believe that any project is as good as the people working in it. So I respect and trust Brian because I know he will never let anyone down. He knows that we perform our best when we feel comfortable. And he goes the extra mile to help everyone, even if it means more work for him. A few months ago, we worked on Raincatcher, a web and mobile open source project to do workforce management. And Brian built a CLI tool just to make everybody deliver faster and better results. In turns, Brian shows respect and trust to me by involving me in all the steps of the process, not just making things look nice. And that trust and respect is a great foundation for good communication.
The second key action we want to keep in mind is to understand the user goals. So we want to start by understanding what the user wants and always keeping those needs in front of mind. It's not about what we want as developers. It's not what about designers want, or even what PM wants. It's all about what the user needs. Tomorrow at 11:30, Tiffany Nolan and Catherine Robson are going to present some user experience tactics for developers. One of those tactics is user stories. So user stories are short, simple descriptions about a feature told from the perspective of the person who wants that feature, usually the user or customer of the system. So they typically follow the simple template. As a type of user, I want some goal so that some reason. So if you do Agile, this probably seems pretty familiar to you. By show of hands, who works in Agile and has done user story like this before? Right. So while working on Raincatcher, we wrote user stories as an instrument to help us design and code with a person in our perspective other than ourselves. So that's how Trevor the truck driver and Daisy the developer were born. They acted as a lingua franca between developers and designers. Right? So Trevor and Daisy and their stories were the light guiding us in our discussions. We would ask ourselves, what would Trevor need? How would Daisy use this feature? Or does Trevor really need this particular UI element to solve this use case?
Right, and we follow a similar process on Bottomfile, a project Brian and I contribute to. Bottomfile is an open source UI framework to build enterprise web applications. And if you're building an enterprise web app, you should check it out because, well, it's awesome. So, and since Bottomfile is dedicated to enterprise users, we started to do a user research to get to know their needs, limits, and issues. And with that knowledge, the Bottomfile community brings designers and developers together to build solutions or UI patterns that not only look great, but also follows good UX practices. And this takes me to the third action, meet in the middle. So leverage the skills of both designers and developers and find where the middle ground is. Use the correct toolings, a place where designers and developers feel comfortable working. Brian and I rely on Git as a central point to share our ideas and build our projects. We write use stories as a lingua franca, and we rely on frameworks like Bottomfile or Bootstrap or Foundation to define our limits and defaults. So these are the three actions. Trust and respect are a great foundation for good communication. Always put yourselves on your user shoes and meet in the middle. And now it's time for a story. And this story started 2 years ago when Brian and I started working together. So last year, we built the Red Hat Keynote Demo. I don't know if anyone was here or actually in Boston by that time when Burst Satters deployed 1,000 containers in under 2 minutes. Well, those 2 minutes took 5 months to build. And it pushes the browser and JavaScript boundaries and optimization and performance to its limits.
So this year isn't any different. The keynote's on Wednesday. We don't want to give away any spoilers and ruin the presentation, ruin the surprise. But we're going to give you guys a sneak peek of one of the pieces that we built and showcase some of the neat CSS and JavaScript that we used to build it. So the story starts on January when Joshua Wilson, a colleague of ours, who's giving a session tomorrow on ES6, go check it out, he had the idea to somehow dynamically create a mosaic up on the big screen. Sounded like a fun challenge, and in today's presentation, we're going to build the DevNation logo as a mosaic out of pictures to showcase the process we used to solve this problem. So being conscientious developers and designers, we started with our developer meet designer principles.
Right. So the first one is to communicate. So we built this project together as a team. And Brian included me in every discussion, even the ones about performance and implementations, even though I'm just a designer. And this proven to be very successful, and we are going to see why afterwards. Then we put ourselves into our user shoes. So before going down the rabbit hole and start typing code, we thought about what's the must-have for this presentation. So as a person in the audience, I would like to see the mosaic build of images, and those images should be small enough to render correctly the original image, so the logo. Then we define 2 things that we would like to have. So as a person in the audience, I would like to be entertained. So I would like to see a dynamic presentation with animations. And then, as a branding team, I would like to see all the images shaped as a diamond to follow all the marketing material of Red Hat Summit you see all around you during this week. Then we think about where we can work together in a space where we will feel comfortable. So we follow a GitHub-based workflow, and we rely on CodePen to build and share our proof of concepts. And this takes us to our demo today. So now Brian is going to kick it off, but I'm going to change the display to be mirroring. Just a sec. Great. So there you go. Wait a sec, yeah.
OK, so if we want to build this mosaic dynamically, we need to be able to and determine its color values at a given coordinate of the image to be able to place a tile on it of the correct color. I don't know about you, but I don't like manual processes. I don't want to have to list that out manually, change it every time we change the underlying image. So we wanted to see if we could use an API in the browser to automate that for us. So we went and created an HTML page with the canvas element on it. You can see it here outlined in the black box. And then in JavaScript, we can create an image element, assign a source to that image. And when that image is loaded, we can go ahead and render that image into the canvas. Right? So this is an image loaded into an image tag, but drawn out to the canvas using this draw image function. So that's cool, but it's kind of small. Doesn't really look like the DevNation logo we saw outside. So we can go and set it to a fixed width. We can inspect the loaded image to determine its aspect ratio, and we can draw the image out in full size. A little bit bigger. Whoops. There we go. So that looks more like the logo we've seen outside. So now we want to be able to inspect this image to see if we can figure out the color. So we can use the getImageData method of the canvas to pull the color data from a pixel 100 pixels in from the left, 100 pixels down from the top. We can get the color data, convert it to a CSS color string, and output it to the JavaScript, to the browser console. This tiny little RGB. I'm not really used to a Mac.
That's my Mac.
So here we go. Andres, we can see the color 255, or sorry, 25, 25, 48. What color is that, Andres?
That must be the blue.
Andres knows this because he's a designer.
Yeah.
All right, so for me, I'm going to go ahead and draw that out to the screen. So I'm going to add this div element, right? And I'm going to update its background color with that CSS color string using this little helper method I created, preview color. So we can see that the color we inspected at the coordinate 100 over, 100 down gives us the blue color. Let's take this one step further. We can make a neat little toy if we use a mouse move event listener. We can follow our mouse as it moves over the image, inspect the color at the coordinate of the mouse move event, and we can update the color of the preview element following the mouse. So here we go. As I move my mouse, I pick up the orange, the blue, the white. All right, that's kind of cool. So we can go ahead, we can load an image into the browser, and we have an API available. We can look at any given coordinate where we want to place a tile, and we can inspect our color. Andres, is there anything you can do with that color information to help us build our mosaic?
Yeah, so we need to be tiles, and those tiles need to be images. And so new browsers are very cool. They are super modern, and they can do things that you designers do on Photoshop. So they can do blending modes, and they can do filters. So we will try to change the image to make it a white filter, an orange filter, and a blue filter with CSS filters and blend modes. So let's start with CSS filters. So CSS filters are one of those things CSS took from SVGs, and they create effects on any element, like blurring, sharpening, or changing the color of an image. So can I use CSS filters? You can. It's 80% globally supported. And for this presentation, we are just going to use Chrome, and then we know we can use it with a prefix. So here I have an image of Angry Birds, and I'm going to add a background here so you can see that this image has an alpha channel. So let me bump this up. Yeah. So this is a transparent image with an alpha channel inside. OK, so let's see which filters are available on CSS. So the first one is blur. And you can blur an image the amount of pixels you want. So you can do it like 4 pixels, or even 4 EMs, or 4 BH. You can choose any unit you want. The next one is brightness. You can turn brightness up, or you can turn it actually down. You can actually do, wait a sec, here it is. Turn contrast up or turn contrast down. You can change the saturation, and the saturation is the amount of color each pixel has. So you can turn it down or turn it up, like this is down, this is up. You can change an element to be grayscale or to be sepia. And you can use drop shadow. And drop shadow is super interesting. The difference between drop shadow and a more traditional box shadow is that drop shadows will respect the transparency, and we put the shadow around the element itself. As in box shadow, we put the shadow around the element the boundaries of the element, or the element that contains the one that has a filter. You can hue rotate colors, and hue rotations will take the color value of each pixel and rotate it in the color wheel scale. So in this case, I'm rotating it 180 degrees, but I can change it to 80 degrees or any amount of degrees I want. I can invert the picture, or I can change the opacity. And the difference between using a filter opacity and the property opacity, the result is exactly the same, but filter opacity has better performance. Now, let me change the picture and use another image here. This is an image we usually see on Instagram. Let me change the opacity here, which is like a bunch of people going to the beach. And with filters, we can add more than one filter and create a style that turns it into an old picture. So I'm decreasing the contrast, decreasing the saturation, and taking a little bit of sepia color on it. So we can see how it looks with and without the filter. Now we need to make the tiles white, orange, and blue. So let's start with a white tile. So let's try to make this picture white. So first, let me transform it to grayscale. Then I'm going to turn the contrast down so it removes the hard black colors. And lastly, I'm going to turn brightness up. So let me do it like 2. And now I can see that the picture originally was like this. And now I turn it into a white tile. Now, I want to create blue and orange tiles. Can I do it with filters? Well, we could if we knew the origin of the color, so we can hue rotate it. But since we don't know which kind of picture we're going to receive, we can't. And that's why we can use blend modes. And if you're a designer or you use Photoshop, you probably know blend modes very, very well. So blend modes takes 2 layers. When you have 2 layers overlay, they do a calculation, and they return a new color value. So in this case, I have 2 layers overlaid, which are 2 images. One of Bill Gates, very young and a creepy position. The other one of Steve Jobs. And I'm going to apply filters to the first image, to the image of Steve Jobs. So there are 5 groups of blend modes: darken, lighten, contrast, comparative, and composites. And they all deal with hue, saturation, and luminosity. And I'm going to show just some of them because we don't have enough time, but they are the one that we use mostly, like all day if you use Photoshop. So the first one is multiply, and multiply leads with luminosity. What it does is it turns every white pixel to transparent, and every black pixel is going to be solid. And any color tone in between is going to get more transparent as it goes down to light. The second one is screen, which is the opposite. So everything that was white is going to turn into solid, and everything that was black or dark is going to turn into transparent. Then on the contrast mode, overlay deals with the midtones and luminosity, and it will blend the midtones. Now, comparative modes are really strange. Difference, for example, inverts the picture or the element that is on top, so the active one, and then it compares it with the one on the background, and if the colors are the same, they will paint it white. So what do we use this for? So here I have a game of spot the difference, and these two pictures are almost the same, but when I apply a filter of difference, I will see exactly where the difference are. So it's almost like cheating.
Oh, no, Andres, I'm sorry.
Oh.
That is cheating.
Right. We are great actors. And lastly, I want to show the blend mode color. And this is the one I'm going to use to turn the things orange and blue. So color turns the background picture into black and white, and it will take the color of the picture on top. Now, let me show you an example of something we do all the time in Photoshop, which is turning some background color transparent when it's white or when it's black. So here I have a piece of paper with the word calligraphy written on it, and I'm going to try to delete or make the white transparent. So how do I do this? I will use a mixed blend mode of multiply, and that will make the white transparent. But you can see that you can still see the texture of the paper. So how can I remove it? So I will use a filter. So if I use a filter of brightness and I push the brightness a little bit up, I will remove the texture. So now I can make the white transparent. But what if I want to make it the other way around? So if I have a background which is darker, so let's say red instead of tan, and I can use a mixed blend mode of screen instead, and this will make the black transparent and the white solid. So now I can use a filter of invert that will invert my image, and it will make the white solid and the black transparent. And this is super cool. These are all things that we couldn't do before. We just could do them with images, and now the browser can do things that Photoshop could do before. So can we use this to generate our orange and blue tiles? The answer is yes, we can. So let's try it. So here I have the logo and free image underneath. The first one has already the filter to make it white, and I want to make the other two orange and blue. So I have a div called mask, which is going to mask the image. And to that mask, I'm going to apply a mix blend mode of color. And then if I add a background, any background, let's say red, the pictures will turn red, but I can change it to, let's say, blue, or whatever color I want. Now, since Brian could get the data from the logo, I have the RGB values of them, so I can turn them to the exact RGB values we are going to use for the mosaic. And I think this is something Brian can use to build the mosaic.
Very cool. So let's go ahead and do that. All right, before we move on to build the mosaic, let's see if we can dynamically take the color data as we inspect it from the image and apply it to using Andres' CSS masking technique. So I'm going to add another preview element here using the HTML structure that Andres gave us and load up the picture that Andres just styled with different colors for us. Now, in my add event listener for the color picker that we created before, I'm going to take the same color string that we inspect, and I'm going to update the color background of the mask element this time. And we should be able to use our cool color picker, and we can see that we can color the image blue or orange. But when we get to white, we have a bit of a problem, right? Because the white didn't work with the color mask, we have to apply the filter. So let's skip down here to our preview mask function, and we're going to check if the color is in fact white. Where did everything go? If the color is in fact white, we want to add CSS class node white, which is going to activate the CSS filters that Andres gave us. So let's go ahead and activate that. And now when we mouse over the orange, over the white, we get the white element. So the next step we have to do is take this image element, and we want to shrink it down in size, and we want to overlay it in a grid on top of our image. Let's see how that works out. So I'm going to add to the HTML, I'm going to add this div container, which I'm calling the mosaic. And it's going to contain the tile images that we want to overlay on top of the mosaic. So the first step I have to do is to initialize our color map. So we inspect the source SVG element. And then we want to resize this image container to the same size as our source image. So you can see it here on the screen with this black border. Let's zoom out a bit so we can see it there. Excellent. So the next step then is to iterate over top of that image container element, and we want to inspect at a spacing equivalent to our tile size. We want to inspect the color of a pixel in the center of that tile over top of that box. So when we come back and draw our images on top of that, we'll know what color to render them. So I created a little helper method to do that called generate tile list. It's going to return a list of tile objects. Let's take a look at what one of those tile objects looks like in the browser console here. Can you guys read that? Not much to see there. It's basically just got some properties of the XY coordinate, the color value, and so on at a given point in the image. So we have a whole array of these tile objects. We're going to iterate over those objects. And we're going to call, iterate over those tile objects and call this drawTile method, which is going to draw out our mosaic. All right, so there we go. We've recreated the DevNation logo now as a series of images. You can't really see it with the resolution provided, but each of those little images is the image that Andres colored earlier. So if we take a quick look at the drawTile method, we're recreating in JavaScript the HTML structure that Andres had shared with us. We're going to create a node div. We're going to add the class node to it. We're going to check if the color that we're trying to draw with that tile is white. If it is, we add the note white CSS class to activate the CSS filter. We're going to create, if the color is not white, we're going to create a new div element for our mask, for our color mask. We're going to give it a background color of the color we want that tile to be. Then we're going to create the image element. We're going to assign to the source property of that image element the image we want to use in our mosaic. We're going to position it absolutely, append it to our node, and then once the image has loaded, we're going to append that node, that dynamically created node element, into our mosaic. And there's one more step I want to share with you. Where is it? Right. So that doesn't really look like a mosaic to me, using the same image. Usually with a mosaic, we'll use a number of different images. So what we're going to do, I have a set of images from Summit that we can use to create the mosaic instead. So we swap it out with a randomly selected image. We get something that looks a bit more like a mosaic buildup of different images. But the neat thing is each of these images then is colored dynamically based on the image we're overlaying it on top.
Cool. So how can we improve this?
Yeah, it looks kind of, we might as well just print this out on paper and hand it out, right? It's not really looking very live, very dynamic. What can we do to, Andres, what can we do here to
So what if we use animations and make the image drop into the canvas instead of making them just there?
That sounds like a great idea.
Right, so let's try to use CSS animations. We are great actors, yeah, almost. So CSS animations allow a change of CSS configurations from one to the other. So it animates from one configuration of CSS to the other. And this is something you can use. It's supported 88% globally. And there are two ways of doing animations. The first one is with transitions, and the second one is with animations. So let's try to make an animation, a transition first. So I have this node here like we had before, and I have a hover state with a transform that scales it to 100%, so double the size. So whenever I put the mouse on top, it will go double the size. So let's try to make a transition from that configuration to the original one. So I type transition, then I give it a time, let's say 0.4 seconds. Then I use the keyword all, which means it will animate all the properties. And then I will use the acceleration function ease. And this will animate the pictures as I move over. The second way to do animations is with animations. So to do that, we set first a set of keyframes. Let me delete the transition here. Yep. First, I'm going to set a set of keyframes. And I'm going to call my animation dropped. So it's going to drop. Then I'm going to use the keyword from. So I'm going to animate from transition, scale, no, sorry, transform, yeah, scale 2, and I'm going to animate it to transform, scale 1. And then to apply the animation to my node, I will use the property animation. I will give it a time, so let's say 4 seconds to make it really slow. Then I'm going to call it with the name, so the name was drop. And then I'm going to use the acceleration function ease. And this will result in animating the pictures. So let's make it infinite, so you can see how it works, infinite. And alternate, so it stops and starts and then goes back and forward. So now I also want to remove the mask as they drop. So when the picture appears, it will appear in the original color, and as it drops, it will take the color of the blue or orange. So I have here another set of keyframes, which I call mask, which just removes the opacity from an object. And then I'm going to apply it here to my mask. And then as I see them dropping, they are going to take the color. And when they come up, they are going to lose the blue and orange color. Now, there are two key things or better things that CSS animations have over more traditional JavaScript animations. The first one is that, as you see, they are really easy to apply and to use. So even for a guy like me that doesn't know JavaScript, we can use animations. The second one is that they have better performance. Since the browser has control over the animations, the browser knows what is going to happen, and the performance is going to be better. So I guess this is something you can use to build our thing, right?
Yeah, certainly. I think a falling animation should add some life to our mosaic.
Let's try it.
All right, so we're going to build on our previous demos. In our first step, we're going to initialize our color map, where we inspect the source image to find the color values. Then we're going to initialize our image container, in which we're going to draw all the tiles. From that, we're going to get back a list of tiles. And we've already seen how we can take that list of tiles, and we can draw them over top our image. And we can get our mosaic. So what we wanted, so we can easily animate these then just by adding a CSS class to our mosaic element, to our image container, that's going to activate the CSS animations that Andres gave us. Let's see what that looks like. All right, so sure enough, they're animated, but they all kind of fell down at once. That's really not very interesting. So let's see if we can have them fall one at a time. Maybe we'll go for a bit more of a rainfall pattern. So at this time, I'm going to introduce RxJS, Reactive Extensions for JavaScript. This is a library that I gave a session on at last year's DevNation. If you didn't manage to catch it, go to the devnation.org website. all the sessions were recorded. At this stage, all I'm going to say is we're going to make use of an observable, of the observable pattern. An observable is like a sequence of events. We're going to use the observable zip function to combine two events, two event streams. One event stream is our array of tiles. Every tile is an event. And the other event stream is going to be an interval, so an event happening over distribution in time. We're going to combine those two, and that way we'll get a tile event coinciding with our interval events. So we can use that then, the combination of those two streams, to draw our tile out, and maybe we'll get that rainfall that we're looking for. Okay, so now we're drawing the tiles one at a time, but this looks more like a wave, still not getting the rainfall that we wanted to get. So it turns out that's really easy to solve. We can take our list of tiles that we draw, and instead of drawing them in sequence, let's just go ahead and, whoops, silly Max. I'm going to go ahead and shuffle the tiles, just reorder the array before we draw it. Oh, and there we go. So now we have the images falling into place over top of the layout. Gives a somewhat pleasant effect, kind of like the images are raining down on top of the image. But we want to be good developers, so let's pay attention to our performance as we're going along here. I'm going to go to the rendering tab of our browser developer tools. I'm going to show the FPS meter. And if we reload the image, we're going to see our FPS. You're going to have a tough time seeing this small little number from the audience. But you can look at the graph. We want the graph, this green line, to stay up here by this blue line. So the blue line represents 60 FPS. At 60 FPS, animations seem nice and fluid. The browser's rendering well. As the frame rate per second drops low, we get this slow kind of chuggy effect. Now this frame rate monitor, in fact, kind of like, well, I'll skip the analogy. It just affects the performance of the browser, right? So by turning on the FPS meter, we actually make the FPS worse. But we can use it to get an idea if we're performing well. So at this stage in the game, I realized we had this performance problem, and I just disappeared down into this JavaScript hole to try and solve the problem. I brought in the JavaScript animation library D3. I switched from using DOM image elements to using SVGs, and I tried to solve the problem by throwing more JavaScript at it.
And actually, when he went SVGs, I also went like deep inside the effects, and I tried something which is called the SVG's Magic Filters. I'm going to show you how it works, even though we end up not using it. So the SVG's filters are much more powerful than CSS filters, and you can do like almost anything with them. And something you can do is manipulate per channel on pictures, so on RGB channels. And that's something you can do on Photoshop, which is like just changing the channels of the pictures. So the way it works is I have here 3 SVGs, and I have the filters white, blue, and orange attached to them. And then I have a matrix. And the matrix is a 4x5 matrix. So the 4 columns represent the R, G, and B channels. Even though it says orange here, it shouldn't say. Yeah, that's right. And the columns represent the R, G, B, and alpha channel, and the last one is a multiplier. So in this case, the second picture, the blue one, it's 1, 1, 1, and 1, which is like the normal color. Now, I know for the RGB values that this should be 0.09, 0.09, and 0.18. And this will turn the image the same blue as the very dark blue of the DevNation logo. And the advantage I have here over using blend modes is that I can still see the original color of the image, even though I'm overlaying the color of the logo. So this is much more interesting. But after thinking about this and doing performance things, we end up dropping the idea, and especially we end up dropping the idea because we can't animate SVG's filters. So we are losing the effect of the changing of the color as it drops. So now continue with your story. Sorry, Brian.
No, that's awesome. I love seeing that stuff. So let's get back to our, change the zoom. Let's get back to our optimization story. So how can we improve the performance in the browser of these animating images? Well, if you think about it, there's a lot of DOM elements on the screen that we're working with at one time, right? I think it takes something between 1,500 and 2,000 of these little tiles to completely cover the screen. You know, one solution is to make the tiles bigger. We would have fewer elements then. But we had our core design principle from the beginning was we wanted to use images that were small enough to still be able to recognize the logo. So how can we get the image count down? Well, it turns out that we can bring back our good friend, the canvas. We can listen for an event called the animation end event that'll tell us when the animation of a tile is completed. When we observe that event, we can take the image, we can render it into a target canvas, and remove the animated element from the DOM. So the canvas is like one big bitmap, right? So as we render the different images into the canvas element, we're only going to have one element in the DOM tree at that given time. So we're going to reduce the number of elements we have to active animations we see on the screen. So let's see how that works. So in our HTML, we're going to add a new canvas element. We're going to call it the target canvas. We're going to start as we have before. We're going to initialize our color map. Then we're going to take the dimensions of the source canvas, and we're going to apply this to our new target canvas. After that, we carry on initializing our mosaic, our image container. We're going to get back our list of tiles, and then we can animate the tiles as we did before. The difference now is we're going to add this event listener for this animation end event. Right? So when a CSS animation completes, or I should say at different stages of a CSS animation, we get these different animation events. Animation start, animation end, animation progress, I think, is another. There's also some corresponding transition events that we can listen to. So we want to listen on the mosaic container for animation end events. We want to check if the target of the event was one of our node elements that we created originally that we use to display our tiles. If it is, if it isn't, we'll ignore it. If it is, we carry on. We can retrieve some JSON from that element that we packed into there to identify the X and Y coordinate and the color and what image we used to render the tile. And then we can create a new image element, load the appropriate colored image into that image element. Once that image is loaded, we're going to take our target canvas, and we're going to render this new image into the canvas at the correct X and Y coordinates of the tile. And then we can remove the element, the animated element, from its parent image container. So let's see how that looks, monitoring our FPS chart as it loads. So here we can see an improvement already. If you look carefully, you'll see a little flicker as the colors of the target SVG canvas don't quite match up with the image filters we were using. That can be tweaked. But more importantly, if you look at the FPS, let's run through it again. If you look at the frame rate per second, we're staying pretty solidly above 30 frames per second. So we're not dropping down to 3, 4 frames per second like we have before. So how can we improve on this a bit further? Well, it turns out that if we disable the animation of the mask element, so now our tiles are going to fall with a solid color, we see that we can achieve 60 FPS. So if we're willing to make the compromise of dropping the animation of the color as the image is falling, we can achieve a nice fluid UI, a nice fluid experience as the animation proceeds.
Right. So how can we improve it even better, like making better?
Well, have you guys seen the summit branding around the site, right? Mosaics are kind of a theme of the conference, but they're not made with squares, are they, Andres?
No, they are diamond shapes. So I guess I can do something with CSS to make them diamond shapes. So there are different ways to do a diamond shape with CSS, but one very new way and cool way to do it is with clip masks. Clip path, yeah, right. So here I have an image, and I can either call an external SVG to render the shape I want to cut it, or I can use a method such as circle in this case. So I can make the image a circle. And if I activate the background, I will see that it's actually transparent, the part that is cut off. And I can make the circle any size, so let's say 130 pixels, and I can move it around, so then let's make it like 40 pixels, 50 pixels, and I can like mask any part of the image. But I don't want to make circles, I want to make diamond shapes, so I have a polygon here with 4 points that represent the points that will mask the image on the diamond shape. So do you think you can apply this to your thingy?
We can certainly try.
Let's try it.
All right, diamond demo, our final demo. So this should be looking familiar by now. In our first step, we initialize our color map. We're going to initialize the target canvas in this step in which we're going to render the images after they fall. We're going to initialize the image container that we're going to use to hold the tiles. Now, with our list of tiles, we're going to animate the falling tiles, all what we've seen in the previous demo. So what we're going to add now is we're going to add the CSS class called Clip, which is going to activate the CSS Clip Path that Andres gave us. And let's see what that looks like. Oh, right, diamonds. Oh, no, they're not landing as diamonds. What's going on? So we have falling diamonds. When the animation ends, we're removing the diamond clipped path, and we're drawing to the target canvas. So instead of drawing squares to the target canvas, we have to change to use diamonds and draw those to the target canvas. So I'm going to skip down to our animation end listener, and when we put the image into the canvas, I'm going to change the source of the image from a square-shaped image to a diamond-shaped image. And now we have our falling clipped path image elements being rendered into diamond shapes when they reach the canvas. But now we have to make some changes to our grid. Right? A lattice of diamonds isn't going to pack up the same way a lattice of squares will. So let's change. I've gone ahead and done this ahead of time. Can you tell? I'm going to change my mosaic initialization to generate a grid of tiles. Right? So every second row, we want to move it over half a square and up half a square. And we'll get back a different set, a different tiles list from that. There we go, falling diamonds, nicely packed together to create a mosaic of our DevNation logo. So now we're going to put on our performance hat again. We're going to look at that FPS, and we see we're not doing very good. The FPS is falling really low. So turns out adding the clip path is going to cost us in terms of frames per second. But we really want those diamond shapes, Andres.
We do, yeah.
What can we do?
Well, something we came up as we were building this. So I came up with the idea of going server-side.
It's really ironic that the server-side solution was proposed by our front-end designer.
Yeah. So how did we do it?
So we went ahead and did that. We used image magic on the back end to clip the images into diamonds. And what does that look like? When we make that change, and we look at our FPS, we can say now we have falling images of diamonds. Now we've retrieved a pre-clipped, pre-colored image from the back end, and we've used that to render our image as falling diamonds, and we maintain our fluid 60 frames per second. We'll look at one more time. All right, there we go, and that brings us to the end of our story. We started out with a bunch of neat APIs, tools, CSS techniques we wanted to explore. We tried them out, we built something, we analyzed what worked, what didn't. In the end, we had to throw some of it away, but we achieved our target goal.
Right, and what did we learn? Well, apart from learning a bunch of things about Canvas and CSS and being fun to work with, we learned that working together as a developer and as a designer, it really paid off. I mean, me having the idea of going server-side, that wouldn't have never happened if he didn't include me in the performance decisions. And this was something that was like communication, middle in the middle, putting ourselves in our user shoes, that helped a lot. So make sure to be there on Wednesday morning. It's at 8:30. I know it's super early, but wake up early, go. It's going to be awesome. If you have any doubts or any questions, we are going to have he's going to be on the Phil Henry booth, on the Community Central. I'm going to be on the Bottomfile booth if you want to talk to us. And we have a few minutes for a question now. Thank you very much.